Okay, I'm going to make a real quick video explaining free body diagrams to you. We'll start out, we'll work a few of these problems and leave the rest to you. Starting out with the basics on free body diagrams, it's a diagram that represents the forces of an object given a situation. This current situation is you got a block resting on a horizontal surface. This question asks us to label the magnitude of the forces. So first of all, we're going to start with labeling the forces. Anytime you're near the surface of the earth, you're going to have a downward force as a result of gravity. So you're going to label that one as force gravity. To calculate the magnitude of this force, you're going to multiply the mass of the object times the acceleration due to gravity on or near the surface of the planet. And since the mass of this object is given to you as 10, you would take 10 times 9.8 and come up with a magnitude of this force of 98 newtons. And because this object is at rest, this is going to tell us two things, two very important things. First of all, it's going to tell us that the acceleration of this object is going to be 0, because rest means it's not moving, not to mention accelerating. So that is 0 meters per second squared. And with an acceleration of 0, it's going to give us our net force. In this case, our net force with an acceleration of 0 is also going to be 0. So we have a net force of 0. So what that means is that when I add all the forces together on this object, that they need to cancel each other out. So I have a downward force, which means this would be a negative, if I was adding it, a negative 98, and I have an upward force. So the magnitude of this upward force I already know is going to be negative, or is going to be 98, and it's going up, so it's going to be positive 98, which will cancel it out and give us a net force of 0. So the question is, what is this net force? Well, it's supporting on a surface, and anytime an object is being supported by a surface, we call that the normal force. So this is the normal force pointing up. And in terms of the last part of this question, does it have any friction force? Friction force is the force that opposes motion. And since this object has no motion, it has no friction force. So the answer to this question is an emphatic no. No motion, no friction. All right, let's move on to the next question. This object is very definitely being pushed, and the question gives us the amount of force that it's being pushed with. So in terms of the free body diagram, we have the same two that we had the last time. It's sitting on a surface, so it has a normal force holding it up. It is on or near the surface of the planet, so it has the force of its mass times gravity pulling it down. These numbers will not be any different because the mass didn't change and gravity doesn't change. So these are still going to be 98 newtons each. And then, as I said, the question defined this. This is a force of 50 newtons, and it is being applied by this person. So we just call it the applied force. And it is 50 newtons, and it is pointed in the right direction as is indicated right here. And this question indicates that this is a frictionless surface, so we do not have to worry about any force opposing this motion. And so in terms of calculating the acceleration of the net force, we would add all these forces together. 98 is positive, it's pointed up. This 98 is negative, so it's pointing down, so that would be 98 plus minus 98, which would be 0. And this is positive because it's pointing to the right. So in terms of our net force, just adding them all together would give us our net force of 50. And so that's 50 newtons. And then we are going to calculate acceleration. Acceleration, the formula for acceleration, is going to be the force divided by the mass. So we have a force, we already said the net force is 50. And the mass is defined by the question as 10 kilograms. So if we take 50 and divide it by 10, we're going to get the acceleration, and in this case that is 5 meters per second squared. And there we go. We'll do one more of these for you, and then we'll let you go ahead and kind of tackle the rest of them. Alright, so this one's a free body diagram where we do have some friction. Same basic scenario as last time. So this is going to be, again, one more time, the force of the mass times the gravity. Mass hasn't changed, gravity hasn't changed, so the force is still 98. Still being supported by a surface, so it'll have an upward force that will be equal and opposite to that of the force of the gravity on the mass. And so therefore that will be 98. The question tells us once again that the applied force is 50. And then it also tells us that the friction force in this case is 30. So it's smaller and it is just labeled friction, force of friction, and it is 30 newtons. So now we're going to calculate the net force, and in this case if we add these forces together, we're going to get 98 minus 98 is 0, and 50 minus 30 is 20. So that's going to give us a net force of 20. And if we want to calculate acceleration, as I mentioned before, that is going to be force divided by the mass. The net force is 20. So we'll divide that by the mass, which is still 10. And that will give us our acceleration of 2 meters per second squared. That is how you do free body diagrams and how you put the numbers to it to come up with magnitudes of the different forces around an object. If you have any questions, please come and see me individually and I will give you further instructions.